Hey guys, this is Coach Lowe and this is 6-3 and we're going to talk about angle bisectors of triangles. So we've talked a little bit about terminology like bisectors. We know that that divides something into two equal pieces. So now we're going to look at dividing an angle into two equal parts and they'll be angles of a triangle. So fun times. Here we go. All right, so talking about an angle bisector. An angle bisector of a triangle is a segment that separates an angle of a triangle into two congruent angles. And by the way, it can be a segment or it can be a ray. So an angle bisector, a ray or a line segment, that bisects the angle of a triangle. Pretty straightforward stuff, huh? So remember, bisecting means it's going to cut it into two congruent angles. So bisecting means this time if it's bisecting an angle, we get two congruent angles, exactly the same measure. All right, so let's take a look at a few problems. Let's say that I have a triangle here. And I'm going to flip this bad boy around here. Make it a little bit different for you. All right, so let's say in triangle, we'll call this A, B, D, that this segment AC bisects angle BAD. So I have an angle bisector. Let me back up just a little bit. Come on now. There we go. So it bisects angle BAD, meaning those two are congruent to each other. This is angle 1 and this is angle 2. If they tell you the measure of angle 1 is 41 degrees, what's the measure of angle 2? Well, if this AC, segment AC, bisects this angle BAD, then these two angles are congruent to each other, so this one would also be 41 degrees. If they ask you for the measure of angle BAD, we should be able to find that now. 41 plus 41, 41 times 2 is 82 degrees. All right, let's try another one. Let's say that I have this triangle and I have a bisector, and this is R, S, T, and U, and SU bisects angle RST. So it is an angle bisector. I want to find the measure of angle TSU, and I'm going to give you some information. This angle is 5 times x minus 1, and this angle is 4x plus 1. All right, and I want the measure of this angle right here. Well, what do we know about these two guys? We know that these two guys are equal in measure, that the measure of angle TSU is equal to the measure of angle RSU, because definition of angle bisector, we know that SU bisects this angle RST. So since we know that those are equal, we can definitely set these guys equal to each other. Do I need that degree symbol on there? No, I do not. I see distributive property here. So I have 5x minus 5 equals 4x plus 1. And now I'll subtract 4x from both sides so that I can solve this equation. That leaves me 1x over here, minus 5 equals 1. I'll add 5 to both sides to finish this up, so x is 6. Now I ask for the measure of angle TSU, not just the value of x. So we have x equals 6, so I will plug it back into the expression for angle TSU. Angle TSU, the measure of angle TSU is 4x plus 1, and when x is 6, 4 times 6 is 24 plus 1 is 25 degrees. So the measure of angle TSU is 25 degrees. All right. Hope that makes sense, guys. We also have maybe just one more thing that we could talk about, and again, we'll be talking about this a little bit in classes. When we have angle bisectors, I actually have 3 of them. So let me get on a different page and we'll draw another triangle. So if you want to do this with me, that would be awesome. Just kind of sketch a little triangle here, and let's draw some angle bisectors. So I'm just going to kind of sketch these in. We'll probably do a little activity to actually bisect those angles. I'm sure you remember how to do that, but we'll bisect these angles. So I'll bisect and go across, and then bisect this one and come across. And as I do that, you can see that these guys cross right here in the middle. And this is called the incenter, the incenter. So where the 3 angle bisector segments meet is called the incenter, and we will look at that a little bit more together in class. So I'm finished, and I'm sure you enjoyed this because I know how much you love geometry. So I will see you guys soon. This is Coach Lowe, and I'm out.